All right. Now, archaeologists have found this broken piece of a plate. And from this, you need to be able to determine a radius, diameter, the circumference. And I know we haven't covered the circumference, but I gave you the formula. 2 times pi times the radius. And I need you to find the center of the plate. Believe it or not, the most important part of this is to find the center of the plate. And from yesterday, there was one thing that we learned. The perpendicular bisector of a chord, is also a diameter. And this is the key to the whole problem. The whole problem says, all right, we have to find the center. What does the diameter do? What is special about the diameter? It goes all the way across a circle, but what special point is on the diameter? The center point. So, no. The center point is on the diameter.
I would appreciate it if we can hold our conversations to none.
All right, so what we need to do is we need to find a couple of these perpendicular bisectors of chords. Now, like I said, all we need is a ruler. And I'm going to draw a chord. I'm going to draw a chord that is 6 centimeters long. So, that looks about 6 centimeters long. Now, what's half of 6? 3. So I'm going to put a dot at 3 that signifies the midpoint of that chord. Now, what I need is something that's going to draw a right angle. And what I've chosen is I'm going to take an index card. I'm just going to fold it in half. And now you have a very, very, very powerful right angle drawer. So I'm going to line up one side here. I'm going to line up the vertex of the right angle at the midpoint. And I'm going to draw that line. And I'll take this and extend that line out, because now I have a perpendicular bisector. But I also have a diameter. So now, over here, I'm going to draw another chord. And this chord is 4. What's half of 4? 2. So, I'm going to draw a right angle here at 2. Which is also a perpendicular bisector, but it's also a diameter. So if I extended this out this way, what do you think that point is? Where do you think all the diameters hit each other? There's our center point. Now, we're not using exact tools. I'm using a pen that is like a 0.7, which is pretty thick for a pen. So it's not going to be 100% exact, but it's going to get us pretty close. So we could go from the center here, and I can open that up to this. And now there's a little bit of an issue right down there, but for what we're doing, this is going to work out really good. So we figured out where the center is. Now, I need to find a radius. Put a point on the circle. And just connect the point to the center and then measure it. And what does it look like the circle is? 1, 2, 3, 4, 5, 6. The radius is 6. The diameter is going to be 2 times 6 because it's 2 radii. So what's 2 times 6? 12. And the circumference is equal to 2 times pi times the radius. Well, what's the radius? This is going to be 12 pi centimeters. This is 6 centimeters. That's 12 centimeters. So I figured out that 6 centimeters from here. Plates are measured in diameter. So this is a 12-inch plate. We were able to calculate this within a margin of error of only a little bit. I did go from the center, and it just missed a little bit down there. But like I said, we're not using exact tools at all. But we came up with a relatively really close approximation, if not exactly what this circle is. And it's a 12-inch diameter. Now, some other things that might have happened were I had to cut and paste this and put it together and do all sorts of stuff. So there's a little bit of margin of error. We made a copy. It might not be the exact same copy, the exact same size, all that kind of stuff. But the methodology is sound. And here's the methodology for solving this problem. 1, draw a chord. 2, find its midpoint. 3, draw the perpendicular bisector. Step 4. Repeat steps 1 through 3 for a brand new chord. Where the perpendicular bisectors intersect, that is the center. Then, pick a point on the circle. Let's put those phones away or else I'll get to keep them. 7. Measure the length of the radius. And then part 8, calculate the diameter. And that is how you solve this problem.